Hey, Pratik, are you there?
Yeah, I'm here. How are you?
Oh, I'm doing pretty good. How about yourself?
I'm good.
Good, good. Now, uh, anything new, anything exciting in your life?
Uh, I don't think so. Not really. Not right now.
Not much. Still waiting into next year, right? For the next test,
Yeah.
driving test.
Yep.
All right. Well, tell me a little bit how the
Um,
class is coming for you.
so we have a workshop on arithmetic, series and sequences on Thursday. Then we have the test on that on the same subject on Friday. And then the following week we have a um cumulative test. And yeah,
Okay. How you feeling about the cumulative test?
I think I'm gonna start working on that because it's like the last chapter with exponentials and logs, the one we discussed, and then it's arithmetic series, or not arithmetic, but series and sequences in general, and then chapter 5, which I kind of don't have any memory about.
Okay. Now, I remember you're struggling a little bit with the logarithms. Are you feeling better about them? Have you practiced them since then?
Well, I got the test back for the logarithms, and I wanted to maybe go over a couple of questions, do them with you because I got them wrong.
Sure.
So,
Let's go and take a look at those real fast.
okay, I'll put them in the bit paper right now.
Sounds good. How'd you do
Um,
on the exam, by the way?
Not too well, but not badly. I mean, not yeah, like a high 80, 86, I think
Mhm.
it was.
Let's see if
So
we can
not
get
what
that
I
up.
was hoping for,
Right.
obviously, but yeah.
How's it put your overall GPA? I know we're a little concerned about that.
My GPA?
For the class, you have to have a certain grade point average, isn't that right? So you don't have to file a petition to get back into the class or for honors class.
Oh yeah, I think no, it hasn't negatively affected or
Okay.
impacted my grade in the class,
Okay. Okay, that's good.
or not so negatively that it's going to impact my course or my path tracking forward.
Okay, so it's just more or less just a bump. It's not a chasm, just a little bump in the road.
Yeah.
Okay, good, good.
Yes. Yeah. Um. So I wanted to go over this problem. I was supposed to condense it, right? And the problem was 2 natural log of x minus 4 natural log of y plus 2/3 natural log of 8 minus um, z plus natural log of x. So I think that was it. And I was supposed to condense it into one.
Okay. And what'd you do there?
I don't have my test, so I can't tell you that because they took the test back.
Okay.
But um, would I? So with these, I would just go in order, right? I wouldn't like pick apart different sections of the problem.
The first thing you want to do is take all those coefficients, put them back on top.
Yes. So log. Okay, I don't know what that was.
Go ahead.
Log x squared minus log y to the fourth plus log of and then
Now, look at this one right here. I want to kind of curious. If you take the cube root of 8 and then you square it, you should get what?
4.
So you can replace that now.
So that would be ln of 4.
Hmm. And actually, there's this other piece back here. We probably should do that one first. That's going to get you 3. So I actually say 3 log of x. Then I would put the 3 on top.
Oh no, I didn't. I just ran out of space. It's kind of like one continuous problem.
Right, right. So you're going to say plus the natural log of x like this, correct?
Yeah.
Okay, so I would first combine, actually. Let's do that real fast. If you were to look at this
Um,
piece and that piece, it's going to be 3 natural log of x. Okay, so lean back up a little bit, give you a hand.
okay.
And then I would throw the 4 on top because there's nothing there else up there. And I think we just said that was going to be the natural log of 4
Yeah.
and the natural log of z squared.
Yep.
Okay, now we'll take that 3 and we'll throw it on top. Okay, keep going from there. Oh, yeah, thanks.
Um, and then it'd be
Yep, yeah, y to the 4. That's exactly right.
okay. I think I get it now.
Okay, now, do you remember what you might have done on the exam?
I think I kind of just I I remember mental computing a bit, so I think that's where I went wrong. And I don't really know because when I do it out like this on paper, it's very easy. So
Right. So my guess is maybe you put too much in your head, too much real estate, you're trying to speed through the problem, and that might trip you up.
yeah,
Okay, so
I agree.
so you can do mental math and you can go pretty fast, but it's good to have anchors as you're going through the calculations to scribble something on a piece of paper if you wanted to do that, so that if you get lost up there, maybe someone distracts you, they come in the room, you're going to lose all the information. So you have something you can always go back to, so you can just keep going to calculations without wasting some more time. So start trying to do that. Start writing out a little more of your work and stop doing so much mental math, and you should be a lot better at it. I know that's one of the things
Okay.
I kind of struggled with too when I was going to college, and because I just wanted to do things as fast as I possibly could and try to do it all in my head, thinking I had to do it in my head too. If you want to be smart, you do it in your head. But someone took me aside, professor, and said, "Hey, look, we can, you know, you had to do the problem, but if you write it out, you'll actually go a lot further because you're not going to forget it." And he was
Okay,
right.
that makes sense. Yep.
All right, let's look at your next problem here.
All right. Um, so my next problem was log 4 of 2x plus 1 equals log 4 of
Okay, now is that towards the bottom of your screen or is it towards the top?
what do you mean?
On my side, it's about halfway down the middle.
Oh, it's on the top for me.
Okay. All right. Well, just keep going the way you're doing then. We'll keep going a little lower on my side.
Okay.
Okay, so you want to solve for x. So you need to do what's the right side?
To the right side, I need to simplify it, combine it.
Right. Go ahead and condense it. And once again, make sure there's a 1 in front of all the logarithms.
What do you mean?
Well, like in the previous case, before we could power things and multiply things, we got to make sure there's a 1 in front of the log. Otherwise, you would not be able to do the quotient property over logarithms if there was a 2 in front. But you do have a 1 in front of all the logarithms, so you're in good shape.
No. Okay.
I'll show you over here. If you come over here to the website, we'll click on the pre-calculus. We'll go over to where it says exponents and logarithms. And here's all your properties for exponents and logarithms again. Before you start using the product and quotient property, there must be a 1 in front of the log. If there's not, then you got to use this exponentiation rule, this power rule, to go about it.
Oh.
Now, if you forgot about the website here, let me go ahead and drop a link into the chat box. You can review these later. All right. Okay, go ahead and keep going there with your problem.
All right. So, all right. So it's log 4 of x plus 1 over 3.
Mm-hmm.
And then is that right so far?
Yeah, I'm gonna have to move that up a little bit because it's going off the screen on my side.
Okay.
Okay, I probably want to subtract it. That's making it a little bit challenging. Okay, so what I would do is I would come back to the second equation you have up here. And notice how both logarithms are to the same base. All I would do is exponentiate by the base, and out tumbles the argument. Then I would go ahead and solve. So as soon as you have a log on one side and a log on the other side, stop doing properties of logarithms, get that x out as fast as you can so you can get it to a rational or a polynomial.
Okay. All right. So then it'd be
Check that. Is that 2 over -5?
yeah.
Okay. Now, after you do this, you always need to go back and check, make sure it's valid. Your argument inside your logarithms can't be negative. You can plug in negative i's for x, that's fine. Just make sure the net effect is not negative.
Right. So -4/5 plus 1, that works. And then -2/5 plus 1, that works. So this should work, ideally.
Yep, that's going to work. So he's go back and check because you might have an erroneous answer. They might throw a problem like that. You got to be careful for.
Okay. All right. And then my last problem was um log 2 of 7x minus 8 minus log 2 of x plus 1 minus 2 of x minus 1 equals 1. Oh, yeah, this one I had a hard time on for some reason. I don't remember why. But okay. So, so first you start out by saying log 2 of 7x minus 8 over x plus 1, right?
Okay. Correct.
And then you continue to say that log 2 of
Now, you see how you just stalled out? Let me ask you the question. Why is this problem a little bit more challenging?
because you have I don't I mean I think I got stuck at this part. I don't remember why it was so hard for me. I just
Yeah. My
so
guess
that is
is,
correct, right? So far?
right. My guess is, though, it's probably because there's a lot of negatives. And what happens a lot is when there's a lot of negatives in a problem, it's a little more challenging to work through.
Yeah,
Now,
that was one of them.
with that mindset, let me show you what you could do to make this problem a tad bit easier. So here you'd say log base 2, 7x minus 8. What if you just factor out a negative for a moment? Okay, so if you did that, yeah, I'm gonna get this up here, right? When you have the addition property versus the difference property, it's a lot easier to maneuver, isn't it? It's just something with subtraction and division that we tend to stumble across. So if I can convert it into a sum or a product, that might be the better route to go. Now, you get to the same spot, but we didn't stall out on our thoughts.
Okay.
We keep making progress at each step. And Pratik, for all things good, leave it in factored form. Don't expand this.
Oh,
The
all
other
right.
problem that students do is they'll try to start expanding because they're so ingrained that you have to expand. You don't have to. Once it's all been packaged up into a logarithm, exponentiate. Okay, take it from there. And let me give you more room here.
Yeah, that's better. Um, so then it'd be 2 equals and then you would do so then it's a quadratic, right? So
Absolutely.
uh,
Then you expand, and then you get a quadratic. And once you have your quadratic, would you factor or use quadratic formula?
is that it?
On the left side, that's correct.
Okay. Yeah. And then okay. So
Right. Factoring is much easier than quadratic formula.
yeah. I'm so bad at this. Oh, I got it. I got it. Okay.
Yeah, 4 and 3. Good.
And then I have to go back and check, right?
Right. See if there's any kind of erroneous solution.
Two. Okay. So 3, 2, 27 over 2 minus 8. That's not a problem. 3, 2 plus 2, 2 equals 5, 2, that's fine. 3, 2 minus 2, 2 equals 1, 2. That's fine. And then what was the other one?
I think that was what, 3 over 2? And
2.
2.
Yeah, 2. So 14 minus 8, 3, and 1. So both of these work?
As long as you don't divide by 0 or you have some kind of other domain violation, such as negative arguments inside the logarithm, you're in good shape.
Okay.
Good.
And I think that was it. Yeah.
Okay. Now, your comprehensive exam, what day is that one?
That one's Thursday of next week, I believe.
Okay. Do you know the topics? I mean, it's comprehensive, but they say focus on certain topics, or it's all fair game?
It's all fair game, I'm pretty sure. It's chapter 5, chapter 6, and chapter 7. Or not
Okay.
7, but series and sequences.
Okay. So we talked about sequences last time, and that's going to be on this next coming exam.
Yeah, I have one on Thursday, and then Friday. Series
So
and
this
sequences.
Thursday.
Yeah.
Okay. For that exam, do you have certain problems you want to look at that they give you that we can work on to make sure you're ready?
Yeah. I'm not sure because
Usually what happens is they ask you things such as arithmetic sequences and geometric sequences, and crack the code, try to figure out what's going on with the sequence, and see if you can put in closed form as opposed to putting in recursive form. Now, have you been working on that since last time we talked in class, or have they been talking about something else?
no, yeah, we have done that. That has
Okay.
been a thing. Yeah.
Okay. Well, good. Well, I can see if I can find some problems, unless you have some problems on your side.
No, I'm just gonna look through all the notes and stuff I have open up here just in case. But if I find anything, I'll let you know. Other than that, you can find some problems. That's okay.
Sure. Let me see what I have and you can see what you got.
Oh, preferably some with sigma notation because we learned about that too.
Okay, let me throw you this problem. Let's see if you guys are talking about this one. All right, are you up for that challenge?
A geometric sequence has number of
Has term t2 equals 3 and t4 equals 18.
Okay. Write any solve an equation to determine the common ratio of Tn. Okay. Oh, I guess not. Okay. Um, so
First thing you want to do is start off and looking at, not that. I would start off by looking at your geometric sequence, its general structure. So let's back up a little bit. So your general structure here in this case, we'll say T of n, and you can say A, and then if you want, call it R. A lot of people do for the ratio. And this is your geometric sequence formula. Start here. This will be your anchor as you work through the problem. Start updating. If you
our
plugged in,
teacher said
okay,
it was a minus one.
okay, that's fine. If you do n minus
Or sorry, n
1,
minus one.
that means you're probably starting off at 1 then for n. If you do the other version, that means you're starting it off at 0.
Oh, okay.
So it just depends on which version you're using. It's going to be okay. All that's going to do is just do a little bit shift, and you're going to be fine. Notice how if you do plug in 1, it's like if you plugged in 0 down below. So let's go ahead and just do it with n minus 1, because it doesn't really matter. Just we'll perturb a little bit. So plug in. These right here are called your initial conditions, IC. Plug them in. So when n is equal to 2, your outcome is 3. And when n equals, actually we're doing minus 1, so n minus 1. And when you plug in 4, your outcome is going to be 18. Now we have 2 equations, we have 2 unknowns, we're in good shape. We can actually solve this. Do a little bit of manipulation. Oops, lied to myself. That should be 3.
Okay.
Now, in order to recover the A and the R, here's what I want to do. I'm going to take one of these equations and I'm going to divide it. Let me color code it so you can see it pretty easy. Now, by doing so, I have 3 goes into 18, 6 times, A goes away, and I'm left with R. And we'll take R to be positive because it's not going to make a lot of sense to make it negative here in this case. So we'll have root 6. As soon as I have this value, I want to come back up to the top, look at my problem statement, update my equation, and then I can plug in initial condition again. You just make your choice. And let's see if I plugged in this one over here in the first one, because that's going to make it a little bit easier. 2 minus 1, get a root 6. And then this tells us that A is going to be 3 over root 6. And if we want to rationalize, multiply by root 6 over root 6. And then update our equation. for the last and final time. The a's can be root 6 over 2. We're going to have root 6, n minus 1. But would you look at that? I can use properties of exponents, push through that root 6. I'm going to add them up, and I get back to the n power anyways.
That's
Okay,
cool.
so that's how you would work these kind of problems.
Okay.
Okay.
Wait, how
Now,
did you get the
go ahead.
1/2 out again? Like, how did you make it from root 6 over the 2 to 1/2 times? Oh, never mind. Got it. Never mind. Got it.
Okay. Let me throw you a problem here. Give me a moment.
Yep.
Okay, so this one's going to be geometric. And if you were to go a of 3, you'll get 2. And if you were to go a of 5, you are going to get 18. What I'd like for you to do is tell me what you're going to need here for your constant and for your common ratio. Figure out the a and the r. Yeah, take the positive case. Will make much sense make it negative.
Yeah. Hmm. Oh, wait. No, I think I did it wrong. Would this be 2 instead of...
That's exactly right. So update that again. That's 2. And the other side is going to be 18.
Yeah, I was gonna say.
Good. Makes the problem really challenging, doesn't it?
Yeah.
So you kind of learn something. If a problem's getting really challenging, go back and just double check, make sure you got everything right.
So then it's 9 equals r squared. So r equals plus or minus 3.
Right.
So then it's n equal 8 times 3 to the n minus 1.
Right. Now, there could be an instance which these could be negative. That's a possibility. We're just kind of staying clear from it for the time being.
Is that when the values would be depreciating or no?
It could be. It could be, but it's all based upon the magnitude really of the ratio. If the ratio is between 0 and 1, you have a depreciation.
Yeah.
If it exceeds 1, it's going to keep growing. If it's less than and it's negative, it's going to alternate back and forth. It's going to be chaotic all over the place. That's why we're staying away from it from being. Okay,
Oh, okay.
how would you find A?
So what I would do is right.
You can
Yeah.
update.
What?
Can you hear me okay?
Yeah.
Okay.
So it was A 9 of 2 and then or 9
No,
over 2.
I
No?
think if you're doing the n minus 1, you plug in your 2. Just let me double check that. Yep. Yeah, okay. Yeah, you're fine. You're fine.
Okay.
Good.
Um,
Now, I got some problems here. They're kind of a challenge problems. It might be a little bit above what you're doing here at the moment. Why don't you take a quick look at these? See if these are the things you're talking about in your class.
oh yeah. We haven't done something like this, especially not the first one.
Arithmetic sequence.
Arithmetic sequence has the first 1,000 terms. Has first term 1,000 and common difference -6. The sum of the first term, the first n terms of the sequence is negative. Find the least value of it. Yeah, we haven't done problems like these.
Okay. Yeah, this is
These are
starting to get into the
beyond.
sigma notation. This is definitely like honors. Is a little beyond what you're doing here at the moment.
Yeah.
Okay. Now, in terms of the sigmas that you're doing in your class, what exactly are you doing?
Like, if I remember correctly, like finding the sum of finite geometric sequences or infinite geometric sequences, or finding the sum of arithmetic sequences, or finding the number of terms in a sequence given the number or given the sum of a sequence or a series, sorry. I meant series in all of those examples. I don't know why I said sequence. But it's like it's like, for example, it would be like n I equals 4, like 3i, or like 2 times 3 equals whatever, right? And then they would give you an x value. You need to solve for n. Just an example.
Okay. Let me throw this to you then.
To find the sums of like arithmetic sequences, series, and geometric series, and
What if you had this? Could you actually calculate that sum?
wouldn't I need maybe. Would this be like 2/3 I or something?
Well, yeah, you can use n or I. It's a variable, doesn't matter what you use. A lot of times you'll see it as i's, j's, or n's.
Okay. So this is a depreciating thing. So they don't give us the
They didn't give you a formula?
no, hold on. So would the first term be 4/9?
Mm-hmm.
Would it wouldn't be 4/9?
First term would be 4/9.
Okay. And then and then this is a okay. So the last term would be 2/3 raised to the 5th.
Mm-hmm.
So 32 over 81 times 5, or 81 times, hold on,
243 or
81
something.
times, so 243.
That would be the last term.
Okay,
But how would you sum
so
this very quickly, though?
and then I would plug it into the formula of like, right?
Almost. Okay, so it looks like the formula that you're using right here, your series starts off at 0. Now, that A doesn't really matter. It's just kind of floating around. Inside here, this is what really matters. You're going to have your 1 minus x, and then 1 minus x in plus 1. Now, up here, notice how it doesn't start off at 0, does it?
No.
So what we're going to do is manipulate this so that it does. Now, there are two different approaches of how I can go about this, but because it is geometric, it does make it a little bit easier. Because what I can employ is properties of exponents. So what I want to do is I want to make sure it goes to 0, so I'll take off 2 down below. Whenever I do that, though, I have to compensate, and I have to add 2 right here. Okay, so let me explain exactly what's going on. If I was looking at the series, and let's say we started off at 2, and let's say I want to go to 4. Well, let's just go up to 5. I would have A2, A3, A4, and A5.
Yeah.
If I make the series starts off at 0, I'm going to add too much to it, am I? I'm going to have A0, A1, A2, A3, A4, A5. Well, I have way too many terms up here. What I need to do is truncate these terms off. I don't want them there. And if I come over here and if I adjust the index, as it's called, and say +2, I plug in the 0 for n, I do get A2. So that properly aligns. I do get A3, and then A4, A5. You have to keep going, I'm not done yet. A6, and A7, 5 terms. Sorry, 6 terms, like it's telling me to do. So I have to make sure that A6 and A7 isn't there. So what I do is I just make sure it stops at the right spot. Here's how it works. Whenever it's called adjust the index. If you take 2 off here, you're going to add 2 over here. if you add 3 here, then you're going to subtract 3 off there. So for this problem, I'm going to take the index and I'm going to adjust it. I'm going to rewrite the series. And then I'm going to employ properties of exponents. I'm going to take this, I'm going to break it apart. Then I'm going to factor out the 2/3 and I'm going to power that thing up. 4 to the 9ths. Then I'm simply going to apply my formula because everything matches now. Matches 0, single power, and something up top. And 3 and 1 gives me 4. Okay, so they start being a little bit more complicated, especially when you start getting away from 0. But we use properties of exponents to bring it back together.
I see.
Hey, let me throw you this one. So it starts off at 3, and we're going to take this and crank it up to 7. And let's throw in 3 7s. Let's say it's n plus 3. Okay, show me how you're going to sum this really fast.
So first you would subtract 3. Subtract 3, so it'd be 4. Is that right?
You're doing great.
And then you would do the opposite of whatever you do up there. So if I'm subtracting 3, I would add 3. So n plus 6.
Mhm.
And then I find the first term, which is 3 7ths to the 6th. And then times 1 minus 3 7ths to the 10, or no, 4.
4 plus 1.
6, 1. Oh, is it because we're starting at 0?
It's because we're starting this formula at 0.
Okay.
Now,
So we're
you
starting
could
at 1.
adjust
What
this
would
start
it
up
be?
at 1. It'd be a little bit different if you're doing that in your class.
Yeah, we usually start at 1. I mean, sometimes we start at a different number, but we usually start at 1. She said that if you're starting at a different number, you should like subtract it from the a in the beginning.
Okay, yeah, there's several things you could do here. Some people start off at 0, some people start off at 1. Probably in your class, starting off at 1 might be a good idea because that's probably things can be tailored towards. Later on, as you progress from your studies, you're not going to start off at 1, you're going to always start off at 0.
I see. Okay.
Yeah, so if you did it at the 0, you just say plus 1 right there. Okay.
Oh, yeah, sorry. So it'd be 3 7ths to the 5, right?
All right, I'm going to throw you one more here.
Okay.
Oops, let me get that out of the way. Okay, try that one. Give a little more room there.
Thank you.
Okay, and that's where most people go wrong. So what you're doing is you're not just tacking it on here at the end. You're making an adjustment on the variable n. So if this goes down by 2, all the n values go up by 2. So replace the n and replace it with an n plus 2. So you don't want to do this. Rather, what you want to do is adjust the n and crank it up by 2 iterations.
So you're adding it just to the n value.
Right, you're doing replacement on the ends. Like we're doing replacement down here, but we're replacing it with 0, replacing this one by 6, we're sort of dropping it down. And I have to drop, or have to raise all the other n values up by how much I drop down over here.
Okay. So
Okay, take it from there.
how would it where did y come from?
Oh, that's a really bad looking 4. There you go.
Oh, okay. And then you have 0 plus 4, so 3/4 to the 4th times 1 minus.
Be really careful. Weren't careful enough. Let me back up.
0 plus 4.
Okay, let's go back. Let's look at the formula. What's on top of the r?
What's top of the r? N, the number of terms.
Was it 2n or just n?
2n.
Well, right here, the formula says n. Down here, we're working with 2n. So you're correct to say pop off that coefficient, the constant, but you need to have an n right there. Properties of exponents comes to play again. Power up to 3, power up to 4. So we're really looking at 9/16. Now, since you have a single n, it's not 2n, now you can go ahead and use the formula. You got to make sure everything matches. 0, n, and a number on top. Okay, let me throw you one more. Try that one.
I understand the last part. So it's 4.
Be real careful. Go back.
So is it n minus 2 or n plus 2?
How many drops did you do on n?
3.
Take the n and replace it with +3. Now, as this drops down, this raises. Okay, keep going from there.
So 3n plus 9 minus 1, so 3n plus 8.
+8, good.
And then it will be so 0 plus 8. So it wouldn't be 5/8 to the 8th.
You do have 5/8 to the 8th, and that's gonna be the coefficient you're gonna pop out. That's your a value.
Okay, so the one in the front, right?
Mhm. Don't do that quite yet. Let's back up a little bit. Rewrite the series now with that 8 popped off. We're going to rewrite it just like this. We don't want to do too much in our heads because then we're going to get a little bit confused. What did the formula tell me for the geometric series?
Say that again.
What does the power need to be to use that geometric series formula? Was it n, 2n, or 3n?
N.
What do I have?
3n.
How do I make sure it's powered up to the n power? Properties of exponents.
I see.
If you have it being multiplied, sneak it on the inside and power it up.
So 5/8 to the 38 to the n.
That's exactly right. So what is that? 125 over 64?
Yeah.
Mm-hmm.
That'd be 125 over 64.
Oh, wait a minute. Not. Yeah, 64. Yeah.
Oh, wait.
No, I'm a
No.
little off here, aren't I?
8
512.
times 65. Yeah.
Long day. 512.
So that would be 125 over 512.
That's your R value.
That's my R value.
Now, I suspect they're going to do something sneaky like this on your exam, where it's just not n, but it's going to be 2n or 3n. Just be very careful when you see that kind of problem.
Okay.
Most of the time, students are just going to tack it on like you did. You just got to remember, you're replacing the whole entire n. So put it inside a set of parentheses and say n plus 2 or n plus 3 and just multiply it out.
Makes sense.
Good. All right, so your exam's on Thursday?
Yep.
All right, well, if you have some questions, you're not for sure about something, send me a quick text again. I'll be glad to help you.
Okay, thank you so much.
All right, we have a great day, and I'll see you next time then.
All right, you too. Thank you. Bye. Have a week.
I hope that today's lesson was a positive and an encouraging learning experience, and that you have a better understanding of how to solve these problems. Be sure to set some time there today and throughout the week to review these concepts, to rework these examples so that you're better prepared for the next lesson. If you need anything, just let me know. You're always welcome to send me an email or to stop by during office hours. Until next time, keep up the good work and have a great day.